Okay, so I want you to imagine strapping a grand piano to your back right at the exact moment you swing down at a golf ball. I mean, just picture the weight of that.
It's a terrifying visual, honestly.
Right. But according to the data, a normal golf swing can place compressive loads on your spine equal to 8 times your body weight. 8 times. So, welcome to today's deep dive.
Glad to be here for this one.
Yeah, our mission today is to just tear through this massive stack of biomechanical research, 3D motion capture studies, physical therapy protocols, and, coaching manuals. We really want to decode exactly how the human body interacts with a golf club to generate power.
And much more importantly, how to actually do it without completely destroying your back in the process.
Exactly, because framing it as this extreme physical stressor is really the only accurate way to look at it, right?
It really is. I mean, golf is uniquely demanding precisely because it requires these violent, high-speed rotational forces while your feet just remain firmly planted on the ground.
Which is not exactly what we evolved to do.
No, not at all. The human body simply wasn't engineered with the modern golf swing in mind. But understanding your own anatomy isn't just, a defensive strategy for injury prevention.
Yeah.
The research points to it being basically the ultimate cheat code for consistency.
I love that. A cheat code.
Yeah, because we're going to break down the exact mechanisms of why your body moves the way it does, rather than just looking at what the club head is doing in space.
Which is such a crucial shift in perspective for you listening. Because think about how many players out there are endlessly buying new drivers or, cycling through random YouTube swing tips to fix a slice.
Oh, all the time.
They are completely ignoring the fact that their body physically cannot execute the motion they are trying to force it into. I mean, you can't buy a technical fix for a physical limitation.
You really can't. If your thoracic spine is locked up, a low-spin shaft isn't going to save your game.
So true. But let's unpack this physical toll, because the underlying numbers detailed in these studies are staggering.
They are. And forget about walking the 8 to 10 kilometers or burning the 600 kilocalories during a round.
Yeah.
Just standing in the golf address posture, just standing there doubles the pressure on your spine.
Wait, seriously, just addressing the ball.
Just addressing it. You go from roughly 100 pounds of pressure when you're standing perfectly erect to 200 pounds simply by hinging forward at the hips to look down at the ball.
Wow.
That is your baseline before you even initiate a takeaway.
Just to stand there. And then the swing itself introduces the real danger. The studies highlight this terrifying concept called the crunch factor.
Yeah, the crunch factor.
Break down the pathomechanics of that for us, because, it sounds like something out of a chiropractor's nightmare.
It basically is. So the crunch factor is this highly dangerous combination of side bend, which is lateral flexion of the spine and high-speed axial rotation happening simultaneously during the downswing.
Okay, so bending and twisting at the exact same time.
Exactly. When a player aggressively drops their trail shoulder down toward the ground while forcefully rotating their torso open to the target, they are exposing the lumbar spine to massive shear forces.
Ouch.
Yeah, it essentially grinds the vertebrae together while twisting them under load.
Hold on, I want to push back on that a bit, because haven't we been explicitly taught to torque our spine as much as possible to generate power?
That has been the traditional advice, yes.
Right, because I feel like for the last 20 years, every golf magazine cover has obsessed over the X factor. Coiling your back like a tightly wound spring to maximize distance.
Well, the modern biomechanical research pushes back incredibly hard on that traditional instruction. The goal in healthy biomechanics is to actually minimize that extreme separation and the associated torsional forces.
Really? So less torque is better?
Yes, because over-torquing the spine does not guarantee a higher club head speed, but it almost guarantees irreparable damage to your facet joints and discs over time.
Man, that's wild.
Creating maximum resistance between the hips and the shoulders might feel powerful, but you are replacing synchronized, efficient movement with violent, injury-promoting muscular contractions.
Okay, so if that traditional coil is a recipe for a bad back, it forces us to kind of re-examine how we actually set up over the ball in the first place.
Absolutely.
The studies draw a really distinct line between spine angle and spine tilt. So spine angle being that primary 35 to 45 degree forward bend at the hips.
Right, the forward hinge.
But spine tilt is the secondary lateral lean away from the target, largely dictated by the fact that your trail hand is sitting lower on the grip.
Exactly. And forcing the shoulders to be perfectly level at address is a trap so many amateurs fall into. If your hands are staggered on the grip, Your shoulders have to mirror that stagger.
That makes total sense.
But beyond just the angle and the tilt, the 3D motion capture data identifies three distinct shapes the spine actually takes at address. First is the C-spine.
Lefty spine. Okay.
This is an exaggerated rounding of the upper back. Think of someone just letting their shoulders droop entirely forward.
Ah, the classic slouch posture. I see that at the driving range all the time. But mechanically, why is that an issue? Because it feels pretty relaxed.
Well, it might feel relaxed, but mechanically, a C-spine locks up your thoracic mobility. When you round your upper back, the vertebrae in your mid-back physically cannot rotate efficiently.
Oh, I see.
Because your body can't turn naturally, your brain compensates by forcing you to artificially lift your arms, which leads to a really steep, disconnected swing.
Basically a chop. Okay, what's the next one?
On the other end of the spectrum, you have the S-spine. This is where a golfer sticks their tailbone way out, creating a deep hollow in their lower back.
Right, right. That's what people do when they try to force an athletic posture. They puff the chest out and stick the butt back.
Yes, and the research warns this is just as hazardous, if not more so, than the slouch. The S-spine introduces severe, premature muscular tension in the lumbar region.
Which means you're tight before you even swing.
Exactly. That tension essentially locks down the pelvis, severely restricting your hip mobility before the club even moves an inch.
So what's the goal then?
The biomechanical ideal is the straight spine. It's neutral, it balances the muscular load, and allows for pure, uninhibited rotation.
Okay, so we're in a neutral, straight spine, properly tilted. Then the takeaway begins. And here is where the data reveals this fascinating benchmark among elite players.
The 1.4 decoupling ratio.
Yes, the 1.4 decoupling ratio. The studies show that during the takeaway, for every 1 degree of adjustment in your forward bend, your thorax rotates exactly 4 degrees.
The implication of that ratio is profound. It proves that rotation leads the swing, while the forward bend merely acts as a stabilizer. You are turning around a fixed axis.
Okay.
If you fail to maintain that ratio, the entire structural integrity of your posture just collapses.
You know, I found it helpful to visualize this like a spiral staircase.
Now, that's a good analogy.
Right. The central pole of the staircase, your spine angle, stays grounded and relatively stable, while the stairs themselves, your thorax just wrap around it.
Spot on.
And maintaining that stability brings up this brilliant biomechanical law mentioned in the sources, the law of opposite pairs. It's essentially a seesaw.
That's exactly how the physics work.
If one side goes up, the other side must go down to keep the system balanced.
Right. Every primary movement in the swing must be countered by an opposing structural adjustment. For instance, if your pelvis tilts forward, an interior tilt during the backswing,
which it naturally wants to do.
right, then your spine must bend and rotate in the exact opposite direction to balance it.
If you fail to create that opposing force, the seesaw breaks. You instantly lose your posture and stand up during the swing.
Which is that classic early extension problem we see in so many amateurs.
The dreaded humping the goat move.
Exactly. And the moment your body geometry changes mid-swing like that, you are entirely reliant on hand-eye coordination to salvage the strike.
Which usually results in topping the ball or hitting it incredibly fat.
Yeah, it destroys consistency.
So if the goal is to maintain that delicate seesaw balance, the physics must completely change the moment you grab a longer club. Because a driver swing feels drastically different from a 7-iron swing.
It absolutely does. And the data from the Frontier study specifically compare the biomechanics of those two clubs. The demands on the lower body are entirely different.
Let's start with the big dog. The driver.
For the driver, we're talking about massive torso rotation and utilizing something called APGRF. That's anterior-posterior ground reaction forces.
Let's define APGRF for everyone, because it sounds like the hidden engine of power.
It really is. It's the force created by pushing backward and forward against the ground to generate torque.
So using your feet to twist the ground.
Exactly. With the driver, you have a longer shaft and a flatter swing plane. To manage that, you explosively push off that trail leg, using the ground to drive your trail hip forward and around. You are creating power from the ground up to maximize that rotational momentum.
Okay, but the 7-iron is shorter, the swing plane is naturally steeper.
Right. And because of that steeper plane, a 7-iron swing shifts the priority from pure rotational momentum to postural control.
Interesting.
Instead of aggressively pushing off the trail leg like with the driver, the 7-iron relies heavily on left foot braking.
Left foot braking. It's like a pole vaulter, right? A pole vaulter runs horizontally, plants the pole firmly into the ground, and that sudden braking action launches their momentum aggressively upward.
That is the exact mechanism. You are using your lead leg as that solid post of support.
I see.
You brake forcefully with the left foot to stop your horizontal slide, which allows the energy to transfer up into the torso and down through the arms, maintaining a consistent downward strike on the ball.
Wow, so you're basically slamming on the brakes to crack the whip.
Okay.
So once we transition down to the ball and transfer that energy, we have to actually square the club face.
Right, the moment of truth.
And the research introduces this really cool metric, handle twist velocity, or HTV. It measures how fast the golfer rolls their forearms to twist the handle right at impact.
Yes, HTV is a fascinating metric.
Now, I always assumed, and I think most people do, that if you're rapidly twisting the handle, having a flippy release, that is a massive flaw. It relies purely on timing and destroys consistency.
That's a very common assumption in the golf world. But the 3D data proves there's actually no single perfect way to square the face, and high HTV is not inherently a flaw.
Wait, really?
Really. Elite pros actually fall into two distinct camps. You have the low HTV players who rely much more on side bend and massive body rotation to deliver a square face, keeping their wrists relatively quiet.
Guys like Dustin Johnson, maybe?
Exactly. But you also have elite high HTV players who rapidly twist the handle and roll their forearms through impact.
So twisting the handle fast is an actual legitimate strategy.
It is. The data showed that HTV alone can generate an extra 1.5 meters per second of clubhead speed. It acts as an independent power source.
An independent power source. That is wild.
It absolutely is, provided you have the world-class hand-eye coordination and timing to execute it consistently.
And there's the catch.
Right. Here is the catch for the amateur golfer. If your body rotation stalls out before impact, your brain will subconsciously force your hands to drastically spike your HTV just to flip the club over and save the shot.
Which is a desperate reaction, not a strategy.
Exactly, it's a rescue mission.
Which naturally brings us to the pathomechanics of the over-the-top move, the dreaded amateur slice. Why does the brain force us to come over the top like that?
Well, it really comes down to a breakdown in the kinematic sequence.
And walk us through that sequence.
The proper sequence transfers energy from the pelvis to the thorax to the lead arm and finally to the club head. It has to flow in that order.
From the ground up.
Right. But if your pelvis isn't level at the top of the backswing, your glutes, which are the primary muscular engine for lower body rotation, physically cannot fire.
So the engine basically stalls before it even starts.
Precisely. And when the lower body stalls out, the brain goes into total panic mode.
Because it knows it still has to hit the ball somehow.
Right. So it recruits the chest and the oblique muscles to yank the club downward and forward. Those specific muscles pull from the outside in, resulting in that steep, over-the-top dive that slices violently right across the golf ball.
Man, that perfectly highlights the overarching theme here, which is the body is the ultimate mobility limiter.
100%.
You cannot simply think your way into a better kinematic sequence if you sit at a desk all day. We talked earlier about a stiff thoracic spine.
Yes.
If you can't rotate that mid-back properly, your brain forces your body to overreach with the shoulder joint just to complete the backswing.
And suddenly you're dealing with a torn rotator cuff.
Exactly. Which is why building a custom physical conditioning plan is non-negotiable if you want to play well and, avoid the surgeon's table.
It really is. But it's about training specific mechanisms, not just doing generic cardio on a treadmill. The physical therapy protocols in the sources emphasize building a physical foundation based on 3 key pillars.
Let's hear them.
First is hip hinging, doing exercises like Romanian deadlifts.
Now, how exactly does a Romanian deadlift translate to a better golf swing?
Good question. It trains the glutes and hamstrings to hold the pelvic angle under heavy load. When those muscles are strong enough to maintain your hip hinge throughout the downswing, you completely eliminate that early extension we talked about earlier.
So it keeps the seesaw balanced.
Exactly. The second pillar is anti-rotation. We just discussed how much rotational force the swing generates. You need core stability to resist and absorb those massive shear forces, specifically to survive the crunch factor.
Right, to keep the spine safe.
The Palloff press is a perfect exercise for this because it trains the deep core to stabilize the spine against a rotational pull, rather than just crunching forward like a traditional sit-up.
And the third pillar is lateral stability. The studies mention lateral band walks to activate the gluteus medius.
Yes.
I imagine that is to prevent the player from swaying side to side, ensuring they turn efficiently around that fixed spiral staircase axis we visualized.
You hit the nail on the head. If the gluteus medius is weak, your hips slide laterally off the ball instead of rotating and completely destroying your low point control.
You're just sliding all over the place. Okay, so we've covered the gym work, but what about right before a round? On the first tee, you always see someone wrapping a driver behind their neck and violently twisting their spine side to side, or holding a toe touch for a minute.
Oh, I cringe every time I see that.
Same, but what does the data say?
The research provides a very clear, practical warning. Never start your warm-up with static stretching.
Never.
Right. When you hold a stretch for 30 seconds, you are actually tricking the muscle into a state of relaxation. That relaxation robs the muscle fibers of the elastic energy you need for high-speed contraction.
So you're basically preparing the body to take a nap, not hit a 300-yard drive.
Right. Instead, you need dynamic movements before your tea time. Walking lunges with twists, leg swings, arm circles.
Keep it moving.
Yes. You are actively priming the nervous system and increasing blood flow. Save those long 30-second static holds for post-round recovery when your actual goal is to flush out metabolic waste and restore resting length to the muscles.
Okay, looking at all this data, the 3D motion capture, the biomechanics, the ground reaction forces, it really paints a vivid picture of where the game is heading.
It's moving fast.
We are moving so far beyond the era of a local country club pro simply eyeballing your swing on the range and slightly weakening your grip.
Oh, absolutely. We have fully entered the era of integration between technology and physical therapy. Systems like Gears and AMM 3D don't just show a video of where the club is, they are mapping out a player's exact pelvic rotation velocities in 3D.
It's basically science fiction.
It really is. They're verifying that 1.4 decoupling ratio and measuring their APGRF in real time. We can now pinpoint the exact millisecond a physical limitation forces a swing full.
And this technological shift is driving a broader, essential trend in the sport: injury prevention.
That's the ultimate goal.
The sources mention the rise of the minimalist golf swing. As we fully comprehend those massive shear forces on the lumbar spine and the dangers of the crunch factor, we're seeing a push toward a style that utilizes a much more upright posture.
Right, protecting the back.
It intentionally reduces vertical dipping and lateral swaying and relies almost purely on horizontal rotation to save the spine.
Because the minimalist approach is fundamentally about efficiency. It recognizes that the human central nervous system really struggles to perfectly sequence the complex multiplanar movements of a traditional highly torqued swing, especially under tournament pressure.
It's just too many moving parts.
Exactly. By standing taller and rotating horizontally, you remove variables, you protect the vertebrae, and you dramatically increase your consistency.
Well, the takeaways from this research are incredibly clear. First, your swing is genuinely only as good as the body performing it. You cannot outcoach a tight thoracic spine or weak glutes.
You really can't.
Second, you have to protect your back. Avoid the hollowed-out S-spine setup and stay far away from the crunch factor by minimizing excessive side bend during your rotation.
Keep it neutral.
Third, respect the physics. Aim for that 1.4 decoupling ratio in your takeaway and understand that swinging a driver requires massive ground reaction forces while hitting a 7-iron demands strict left foot braking and postural control.
Perfectly summarized. But, reading the research isn't enough. Knowledge is only valuable when it is applied to your specific anatomy.
Right.
We've discussed high-level biomechanical theory today, but you need to uncover how it applies to your body. Getting a proper physical assessment from a certified biomechanics professional is crucial to find your specific mobility limitations.
Because generic fitness programs will only ever yield generic results.
Exactly. You have to find out exactly what your unique body needs to swing freely.
Well, I want to leave you with a fascinating historical nugget from the sources to mull over as we wrap up. We spent so much time today dissecting the danger of the forward spinal tilt in golf and the massive compressive loads it creates on your back.
The 200 pounds of pressure at address.
Right. Well, it turns out that specific posture likely originated simply because the earliest golfers were Scottish shepherds knocking pebbles into rabbit holes using their short crooks.
It is amazing.
The tools they had were short, so they had to bend over. It makes you wonder, if we invented the game of golf today, utilizing everything we just learned about human biomechanics, 3D kinematics, and spine health, would we ever design a club that forces us to bend over at all?
Probably not.
If we didn't use those short crooks, we wouldn't have a grand piano strapped to our backs every time we swing.
Something to think about during your next round.
Definitely.
If you enjoyed today's episode, please subscribe to our channel and share it with fellow golfers, coaches, and golf professionals. If there is a topic you would like us to research, analyze, and discuss in a future episode, feel free to send us an email. Our team will evaluate your question, conduct in depth research, and may create a dedicated podcast episode focused entirely on your topic. Thank you for listening, and we look forward to exploring the future of golf performance, coaching, biomechanics, kinematics, ground reaction forces, and technology together.